Let us now discuss the language accepted by a DFA. Language of a DFA N is denoted as L of M and contains all the strings accepted by N. We say that a language L dash is accepted or recognized by a DFA if L of M is equal to L dash. For a DFA, which we already know what it is, M is equal to Q sigma delta Q0F, we say that a language is accepted by M if it accepts all strings of type W such that delta star of Q0, W belongs to F. Now what does that really mean? It means that given a string W, which is a function of sigma star, that is the input alphabet, and given a transition function delta, if we start from start state Q0 and make transitions for the given input alphabet W and reach one of the final states, then this string is accepted by the given language. And the language is rejected by M if it is exactly the opposite of it. So now here we start with delta star Q0W and the transitions happen in such a way that the final state that we reach is one of those which is not the actual accept or final state. Some more examples of DFA, let us discuss them. This is a language which is actually an empty language, and this diagram represents the DFA for an empty language. The diagram to the right represents a language of all strings. So some of the strings that are represented by this DFA can be enumerated as, say, AB, AB, or AAB, just a simple A, or simple B, and so on. This DFA represents the language of the empty string lambda. So now we are saying that it accepts null language as the input string and everything else is rejected. Now let's try to see one more example of a DFA and try to understand which language does it accept. So this language represents all strings with prefix AB. The DFA here represents all strings with prefix AB. Given this DFA, can you enlist some example strings that would be accepted by the DFA as well as those that would be rejected by DFA? If you try to do that, let's try to actually do this together. So we start in state Q0 and one first accept string that we can make is, say, A followed by B, because that takes us to the final accept state. So one of the accept states or accepting strings for this DFA is AB. And another example of accepting string could be A, B, and then A maybe one more time, or any more number of A's and B's. So one example is AB, other is A, B, 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 third could be A, B, A, A, B, B. These would be examples of strings that would be accepted by this DFA. As against this, an example of a string that would be rejected by this DFA will be B, starting with B and then any number of A's and B's, because that means that this string, if it starts with B, it certainly does not have the prefix AB, and that takes this DFA to the trap state. Similarly, let's have a look at the example here. This represents all binary strings or this DFA represents the language of all binary strings containing substring 001. So, 4 examples of possible accepted strings could be, say, 0, 0, 1. Second example could be, say, 0, then maybe 1, then maybe 0 again, then 0, 1. Another example could be, say, 0, 0, 0, 0, 0 and 1. Now can we also enlist a few examples of strings that would be rejected by this DFA? One such example is just say a simple 1. This would be rejected. Another example could be say 1, 0, 0. So the point to drive home is all such input sequences which do not take us to the final state represent strings which would be rejected by the given DFA, and vice versa. So that takes us to the definition of what is accepted by a DFA. So a language L is regular if there is a DFA M that accepts it. And these languages are called as regular languages. So the languages accepted by all DFAs form the family of regular languages. Thank you.